Welcome to the tutorial video on squaring binomials. While the topic is not too difficult, it is a crucial part of being fluent in algebra, and often trips up students when they move through it too quickly. Mastering this skill will make your future work in algebra easier and smoother. A binomial is an algebraic expression consisting of the sum or difference of two terms. For example, x plus 6, or z minus 3, or x plus y, or 4a minus 5b, or even 1 plus 2. Okay, you probably never encountered that last one. Most people would just write 3, but it fits the definition and can be useful for illustration purposes. It's very common to encounter the square of a binomial, both in theory and in applications. The key thing to remember is that squaring something is just multiplying it by itself, so we can use the FOIL method to find the product. As a reminder, FOIL is an acronym for the order in which we multiply out the terms: first, outer, inner, last. Let's take x plus 2 quantity squared. The first factor in each parentheses is x. The outer factor is x in the first parentheses and 2 in the second. The inner factor is 2 in the first parentheses and x in the second. And the last factor is 2 in each parentheses. Writing these out, we have x times x plus x times 2 plus 2 times x plus 2 times 2, which we can multiply out as x squared plus 2x plus 2x plus 4, and then simplify to being x squared plus 4x plus 4. There really isn't much more to it than that, if you remember that it's just a product. Here are some more examples. 2x plus 5 quantity squared is 2x times 2x plus 2x times 5 plus 5 times 2x plus 5 times 5, which simplifies to 4x squared plus 20x plus 25. It really doesn't matter how complicated the binomial appears to be. For instance, 3p plus 2q quantity squared ends up being just 3p times 3p plus 3p times 2q plus 2q times 3p plus 2q times 2q, which multiplies out to and then simplifies to become 9p squared plus 12pq plus 4q squared. You have to pay attention to the signs, of course. Now the first factors are still x and x, but the outer factors are x and minus 3. Likewise, the inner factors are minus 3 and x, and the last factors are minus 3 and minus 3. Notice how the minus 3 squared still became a plus 9, because that's how negative numbers work. Minus times minus is plus. An additional common student error is to forget the extra terms. That is, many students will write that x plus y quantity squared is x squared plus y squared. They just apply the square to each term, but this is not true. You can remind yourself that it's false by plugging in numbers, since x and y are actually just actual numbers. For instance, 1 for x and 2 for y. 1 plus 2 all squared is the same as 3 squared, which is 9. But 1 squared plus 2 squared is 1 plus 4, which is 5. They are not the same. There's a shortcut that can save you some time if you remember it and apply it. Let's expand x plus y quantity squared. X plus y quantity squared, which is just x plus y times x plus y, has a first factor of x times x, and then x times y, and then y times x, and then y times y, which we can combine to become x squared plus xy plus xy plus y squared, which is x squared plus 2xy plus y squared, which we could rewrite as x squared plus y squared plus 2xy. We see that this can be interpreted as square the first term, square the second term, and then add in twice the product of the terms. And since x and y represent any numbers, this is always true. We can get the square in only one line. Here are some examples. They might seem a little familiar. To find the square of 2x plus 5, we square the first term, 2x, and get 4x squared. We square the second term, 5, to get 25. Finally, we add both of these to twice the product, or 2 times 2x times 5, which is 20x. so the whole thing becomes 4x squared plus 25 plus 20x. Likewise, to get 3p plus 2q all squared, we take the square of 3p, that is 9p squared, and we add it to the square of 2q, that is 4q squared, and add in twice their product, or 2 times 3q times 2p, or 12pq, leading to 9p squared plus 4q squared plus 12pq. These are, of course, exactly the same results as we found earlier using FOIL. Either method works. Use whichever one appeals to you. If you have the difference of two terms instead of their sum, you just subtract twice the product instead. As an example, 3 minus z quantity squared is the square of the first term, that is 3 squared, plus the square of the second term, that is z squared, minus twice their product of, or minus 2 times 3 times z, leading to a final answer of 9 plus z squared minus 6z. And really, that's all there is to it. Be sure to try the practice problems to cement your mastery of the skill.